instead of T of S, it becomes T of J omega. What happened to the sigma? I ate it up today. I'll tell you why on Wednesday. This is 1 plus J times star, which is times omega, because S is J times omega. Look at the numerator, I'm writing it as 1 plus 0 times J, no harm done. What's the magnitude of the complex number T of J omega? It's a ratio of two complex numbers whose magnitude is the magnitude of the numerator by the magnitude of the denominator. Magnitude of the numerator is 1. Magnitude of the denominator is 1 plus tau square omega square square root. Do you see this creature in our solution? Right? Do you see that exactly sitting right there? Forget the A. It's 1 by square root of that term. Then the other thing, what's the phase? This is called the phase. This is the magnitude. If I look at the phase is the phase of the numerator minus the phase of the denominator, which is tan inverse, imaginary part by the real part, so 0 by 1, minus, look at that, phi 1 minus phi 2, minus tan inverse tau omega by 1, which is nothing but minus tau omega tan inverse. I want to clear this for the last line of the day. I can now write Vc of t a magnitude of the transfer function sine omega t plus the phase of the transfer function, which means that if I have a harmonic input to the system, I do not need to solve for anything except the transfer function of the system. If I know the transfer function, I know completely how the output is going to be. The output will be modified by the same magnitude of the input, right? This was the input. I'm given this, that goes directly there. I know to find transfer functions, we all know how to do that. If you know how to find the transfer function, magnitude, phase, no need to spend time solving it. All we have to do is now perform the analysis. And the analysis is going to be done in the frequency domain using Bode plots. Okay, thank you.